Okay, we're going to do science and soils now. I apologise, but I don't know another way to set this up, so I've got to do it the long way around. So this unit, this week we're going to look at the science and soils, and then give you lots and lots of ideas on different experiments that you can use in class as well as out in the paddock. So the definition we have of a soil is that it's a loose top layer of the Earth's surface, and it has rocks and minerals and particles which are mixed with decaying organic matter, which is called humus. Without it, we can't live on Earth. It provides all the nutrients for the plants for growth, and it supports a whole range of biotic communities, which we'll look at. So all soils, as we mentioned, it requires nutrients and organic matter. Organisms in the soil, such as bacteria and fungi, worms, beetles, ants, and termites, they all help to create the nutrients and maintain a balance in the soil. So the nutrient elements that are essential for plant growth can be divided into three groups. So the major elements that you'll hear a lot in agriculture is NPK, or nitrogen, phosphorus, and potassium. And you'll see big bags of fertilizer at some of the big ag shops, and you can buy NPK, and that they use it as an all-purpose sort of fertilizer. And then we go to the secondary elements, which they need for plant growth, as well as calcium, magnesium, and sulfur. And then we've got our trace elements, which are iron, copper, boron, manganese, molybdenum, and zinc. But the three that students really need to know about, in especially stage 4, is just get used to the term NPK, nitrogen, phosphorus, potassium. Okay, so humus is something that some farmers are starting to click onto, that they can't just keep fertilizing and processing their soil. The soil is basically dead because it's such a thin layer that they use to develop crops. So the humus is it's decayed plant and animal matter. It improves the soil structure. So we talk a lot about structure, and soil is in like little platelets that are held together by positive and negative ions, and you take those out. As well as the biology of the soil, it's basically dead. So when you put humus in, it helps the soil structure. It makes it crumbly and it aerates it. It improves water. So farmers will always look at moisture content in soil, and the ability to support plant growth. So humus is also, it's organic. It's non-cellular. It's a long-lasting component of soil. It's organic because it contains mostly stable carbon compounds with no phosphorus, and there's hardly any nitrogen in the soil, which is another interesting topic. It's got good nutritive qualities, and it's got trace elements, and so it's really important to have what they call humus in the soil. Now, some possibly might get it confused with compost. So compost is different from humus in that it's composting organisms, and it's carbon for energy. So you need the energy for microbial oxidation of the carbon processes, which produce heat. It needs nitrogen to grow and produce more organisms to oxidize the carbon. So if you put in green manure, which is like green grasses and weeds and vegetable waste and prunings, that will help with the nitrogen. And oxygen. So you need oxygen in the soil to oxidize the carbon and to enable some sort of decomposition process. And the other thing you need in compost is water. So the right amounts of water will also will help the microbial process. So when you have a worm farm, you need to have, because they that's compost. They're breaking, the worms are breaking down all the material, the vegetative material. So you need to give, a little bit of water into the worm farm as well, but that's another area. So compost. And the next thing we need is soil pH. I'm sorry my slide's not showing the whole way, but soil pH is really important for soil, and most plants will only grow in a range of about 6 to 7 pH. So here we go. So soil pH, so the pH range is around 6 to 7, and that will allow the plants to take up the nutrients. If it's too acidic or too basic, the plants won't take up the nutrients. So the soil pH can influence plant growth, and it can also influence the microorganisms in the soil. So there are probably lots of other things out there, but lime generally is used to decrease the acidity of soils. So it increases the pH. So an acidic soil is low. It's around 2 or 3, and then as you get up to the alkaline, then it's going up to 9s and 11s, and I think 14 is the highest. Okay, so here's a simple chart of what's extremely acidic. Now kids, again, they confuse acidic and the bases and the acids, and they'll switch them around, which is really common. But it's basically around these areas that 6 to 7s that plants like to grow, except for blueberry plants. There are some plants that like to live in acidic, or like to have acidic soil, and blueberry plants are one of them. So it's just a guide. Okay, so when we look at soil texture will vary according to the composition, and as soil slowly forms, it sort of sorts itself out into layers, which are called horizons. But so the soil texture, it's going to vary according to the type of mineral composition and the parent material, where it's coming from. So I should have done this probably the other way around, looking at a soil horizon, because down below are the parent materials, and as they erode with water and wind and just general erosion, they start to make these different soil types, and they'll have different soil textures. Okay, so clay is one of these soil textures, and heavily clayed soil, which we actually have out in the Central West, but they'll have usually some loam or sort of an alluvial soil. That's the best soil that you want for your cropping, because the clay soils are very dense, and they're not highly aerated, and it's really difficult for plants to sort of take root in the soil. And then there's silt. So silt is more of a solid. It's sort of dust-like, and it's very fine, and it's a sediment that's been worn away by water and ice and wind transport, and it's moved away as a deposit. So it's made up of rock, mineral particles that are larger than clay, but it's smaller than sand. So, and it's really slippery when it's wet. It's not grainy or rocky, and the soil can be called silt if it's got a greater than 80% when it's worn away. So these are just some children playing in mud, which kids like to do. And then there's sand, and sand is again naturally occurring. It's a it's a finer rock and mineral, but it's larger than clay and silt particles. So it's defined really by its size. Okay, and just two really quick experiments that you can do with students. And I've got a whole list of stuff that you can do in the other resources, but you'd look at that in your own time. The traditional one is field texturing. So you can give students a range of soil samples and they make it into a golf ball, and then they moisten it with a bit of water and they knead it into a ball. And they continue working with it and adding more soil and water, and if it no longer sticks to their fingers, or four fingers, and that if they can turn it into a ribbon, things like that are difficult for sandy soil. Now I've got some simulations you can play with. I've got the experiments in resources, and you can ask them heaps of questions, and it's really quite a good test to use. And the other one's the shake test. So you're giving them different soil. Well, you're giving them a soil sample. You're just separating it, and then they can start seeing what's going to the bottom and what's still up at the top, and they can start seeing the different groups and how they divide. And one of the really important things, this might not work so much for stage 4, but getting them used to the fact that there's actually a chemical an electrical system that's in soils, and it's set up by the elements, the P's and K's and the calciums, and they all have positive, negative charges. And in those platelets, that you've got negative charges, and if you don't have your positive charges, which hold the the elements like the phosphorus and the potassium and the calcium, it just, all the elements just wash out through erosion or whatever, or through tillage. And I think in stage 4 it's just interesting. I think it's important to get them used to the fact that there's some sort of electrical charge in there, and if you show them the periodic table, they can start seeing the different charges, and just getting it into their minds. And then of course you can extend with your brighter students, the ones that are more curious about, they don't even have to be brighter, they can just be curious about what this all means, and really start bringing in the chemistry. It's really fascinating. Now I've just done the phosphorus cycle. I should do the nitrogen cycle as well, I think they have the nitrogen cycle in year 7 science, that just reiterate. And really there's not a lot of nitrogen in the soil. It's the bacteria that break down in the roots, the ribosomes, and other ways that bacteria bring in nitrogen into the soil. So the importance of these cycles can be highlighted again, because they'll come across cycles in year 7. And there's a map of how it, we all probably have a map of this in our science classes. And then lastly, I just want to quickly touch on biodiversity in soils. This is so fascinating, especially right now. They're discovering all these sorts of interactions that fungi and mycelium and bacteria and all these the nematodes, all this symbiotic relationships that they're discovering, especially with mycelium. And it's like this little world underneath of of connection with the trees and life, and that mycelium might be very particular just to that area, that diversity, that interaction with with the web of life, which might not work in other areas. So mining companies say, oh yeah, we're putting back the same vegetation. Well, they really can't, because they've destroyed the soil structure. So it's I'm just touching on it here. Just it's just so interesting. And I've put, again, heaps of resources and materials to look at. And that's it. So enjoy the resources. Have a chat on the discussion line. Share your experiences with teaching things that might pertain to soil, or if you're an ag teacher, maybe you could try some of the science experiments further. Maybe you already try them. Have a conversation. Okay.